Hello and welcome to lesson 9-8. Today we're going to look at factoring polynomials when they have four terms. Okay, so we're going to look at factoring polynomials that have four separate terms in them, which will be a little bit different than when we factor a trinomial or a binomial or something like that. So to factor a four-term polynomial, what we're going to do is we're actually going to use a method that we call grouping. Okay, so with grouping, what we're going to do is we're literally going to group together with parentheses two terms. So I'm going to put a set of parentheses around the first two terms, and then I'm going to put a set of parentheses around the second terms. Now, sometimes grouping can't be used, but if it can, then this is how we're going to do this, okay? And I'll show you in just a minute how you can tell whether or not this is going to factor correctly with the grouping method. So what I'm going to do is I'm going to look at the first group, and the first group is x cubed plus 3x squared. So what I'm going to do is I'm going to factor out anything that I can. And in this case, I see that both of those terms have an x squared term. And then what's left is going to be an x plus 3. I'm going to bring my symbol down, the plus sign, and then I'm going to look at my second group here, and I'm going to do the same thing. I'm going to take out the common factor. So in this case, 4x and 12 both have a 4 in common, and that's going to leave me with an x plus 3. So in order to tell whether or not the grouping method is going to work, once you've factored out of those groups, you must have a common group. So if you notice, I have an x plus 3 from the first group, and I have an x plus 3 in the second group. If those groups are not the same, you cannot use grouping as a method. But because they are, then what I'm going to do is I can now create my factors, and one of those factors is going to be that x plus 3. So I'm going to write x plus 3. And then my other factor is going to come from what is left. So I have an x squared, I have a plus, and then I have this 4 right here. So now I can see that I have x plus 3 times a quantity of x squared plus 4. Now I can't simplify this x squared plus 4 anymore because it's not a difference. Therefore, I can't use the difference of squares. So with that being said, that tells me then that these are my two factors, and if you were to FOIL these out, you would end up with this polynomial right here. So let's take a look at example 1. Example 1 says to factor 5x to the fourth plus 20x cubed plus 6x plus 24. So because I have four terms, I'm going to go ahead and try the grouping method from the get-go. So when I do this, I notice in my first group, I have 5x to the fourth plus 20x cubed. Well, I can take a 5x to the third out of both of those terms. And what that's going to leave me with then is an x plus 4. I have a plus, and then between 6x and 24, I can take out a 6. And again, I'm left with an x plus 4. Well, because these two terms right here are the same, that x plus 4, that tells me that I'm able to factor this. Therefore, my first factor is going to be x plus 4. And then my second factor is going to come from everything that's left. So I have 5x cubed plus 6. And now I have completely factored this polynomial because I can't simplify the 5x cubed plus 6, and the x plus 4 is completely factored as well. Now with example 2, I'm going to do the same thing, and I'm going to group my first two terms, then I'm going to group my last two terms. So in my first group, I'm going to factor out a 4x squared, and that's going to leave me with an x plus 2. Now in the second factor, I'm actually going to factor out a negative 5, because if you notice I have the subtraction sign, well, that subtraction sign is really like a negative. So if I take out a negative 5, then that's going to leave me with a positive x on the inside, but 10 divided by negative 5 is really going to give me I need to end up with a positive 2, because negative 10 divided by negative 5 will give me a positive 2. Now, if you want to verify that, if you take this negative 5 and you multiply it by that positive 2, it should give you this negative 10 right there. Okay, so now if I continue on, notice I have the same factor of x plus 2. So that means that this is going to factor by grouping. And then I'm left with 4x squared minus 5. And these are my two factors because x plus 2 can't be simplified. And 4x squared minus 5, although it's a difference, the 5 isn't a perfect square, so I cannot factor that one anymore. And for our last example, we have 2x cubed plus x squared that I'm going to group together. Then I'm going to be subtracting 14x minus 7. So I'm going to put those into a separate set of factors. And between my 2x cubed and x squared, I can factor out an x squared, leaving me with a 2x plus 1. I have a negative, so I'm going to factor out, it looks like I can take a 7 out of both. And that's going to leave me with 2x. Now, let's say I forget, okay, to factor out the negative 7 from this 7 right here. Because right now, as it stands, if I take a negative 7 and I distribute that onto a negative 1, I'm going to get a positive 7. Okay, and another red flag that I have is if you notice, I have 2x plus 1 right here and 2x minus 1. So because the numerical values of 2x and 1 are the same, they're just off by a sign. Usually that's kind of a red flag to myself too, and I have to double check and say, hey, did I forget to divide by a negative? And in this case I did, which isn't a big deal. All I have to do with that is I just have to go and make this a plus because negative 7 times a positive 1 will now give me that negative 7, which is what I should have had. Okay, so now that I know that I have my correct factors, it looks like 2x plus 1 is my common factor in both, and then I'm left with an x squared minus 7. Now again, I'm just going to double check. 2x plus 1 is a linear factor, so I can't factor that one out anymore. And then my other factor, although it's a difference of squares, I can't take 7 and get it's not a nice perfect square, so these are going to be my complete and final factors for this. Please let me know if you guys have any questions. Otherwise, I hope you guys have a great day, and we will see you in class.